Hello, welcome to another video. So this one I want to play a game, but I also don't want to play. So the game I do not want to play is this little thing here, which this keyboard I've got is terrible for that. That was a weird little thing. Oh yeah, the yeah. I don't know if you're hearing that. Oh no, like that's gone. Anyhow, I don't want to play that. The reason is not because my keyboard is not the best. I get that. The reason is actually I want to do some exploring and try and work out, like how it works. More specifically, there's well, we can have a look at what the files are. There's a out. There's Yeah. So it's got like a bunch of things. It's got like some SBL files, bunch of CGA files. DOSBox can ignore that. Quite a bunch of CGAs. Dat file, com, more SPL, CGA, icon can kind of ignore that. Spidey, this is like the main executable and a couple more CGAs. So what I kind of want to do is work out what the format of these are, and in particular, I kind of want to figure out this rooms.sbo. And to be honest, I've actually had a little help. What is it? Cold Iron on YouTube. He also does some Spiderman type things, and uh, he wants to do a fan remake, and I was like, well, I know a bit about assembly, so I thought I'd give it a shot. So he's kind of looked at the files. So I mean, if you look at rooms.sbo, you can kind of see like a bunch of stuff in there. There's a fair amount. So maybe if we type that through, is this big enough? Maybe we'll go up to that sort of thing. Um, so it's got a bunch of things, but you can see here that it's got like midnight down there, and if we look down, there's Black Thunder there, and there's Lift. So there's kind of some room names here, and a bunch of other stuff scattered about. And he's actually done a decent job. So like this A out is kind of my reading of his email to try and work out how to do things. I still haven't got the compression around my head yet, but this is kind of a room has some tiles and it's says what background it has, which comes from the backstop SPO, and it's got a room to the north, east, south, west. Hands aren't doing the right thing. It's got a couple of unknown bits. We'll work those out. Got some gravity, so if you tweak those, different things happen. And it's got some name and it's got some more stuff. And we'll get to that. But anyway, the purpose of this video was more to take a look at this tool, ghidra. So it's a tool that was like released by the National Security Agency, so it must be secure. It also means that it looks really clunky. It has improved somewhat since it's become open source, but yeah. The gist is that you can kind of load up a executable and it will do some stuff, and um, it will like decompile a bunch of stuff. It won't always do the best job. I'll just clear up some space on the screen. I don't know where I am. I'm around there somewhere. But it kind of drops you into entry. So what I've been doing last couple of evenings is kind of looking through this. And with assembly, you really do have to look line by line to work out what it's actually kind of doing. So I've kind of put comments along to work out what's happening at every point, and we get some stuff. I haven't set that actually. And I'm also down the bottom having a little memory map. Or do I put that somewhere? Um, and so because it's assembly, you've got like a couple of interesting things that you've got to keep around your head at all points. So there's a bunch of registers. I have got another video about registers. Now in this program, it's actually 16-bit, so this is real mode stuff. So you will only see these two character registers, which means it's only 16 bits unless it's a H or an L, and then it's just 8 bits, and it's like a different view of that biggest 16-bit thing. Because I don't know, Intel thought that would be good. Don't need this, I realized. So what happens is we start up and we set some special registers. So we've got an extra segment register and a data segment register. Now these are important to set quite early on, and if you look through my operating system videos, you'll see that I set a bunch of these fields reasonably early on. And the point of these is to say when I'm looking up memory, so for example, here I'm looking up some memory, where should it go? So ghidra has kind of worked out where it's meant to go, because this is meant to get put into, I believe it goes into DES, because this is a bit of data. The ES comes into play in certain what do you call them? Opcodes, I guess. Will use different things. But yeah, so here it basically says that I'm looking for a memory address, and it will write it kind of like this. Where's a good font? Let's dismiss that. No, that's why I'm saying dismiss. So if we what was I saying? So you basically have an address, and you have four hex digits followed by another four hex digits, and uh, I don't know. Say this is like A B C D, and followed by X Y. W, Y, Z. This means it's going to look at the address ABCD times 0x1000, or maybe just that many O's, plus W, X, Y, Z. Most people don't really care about how that number is generated and just focus on this by setting the various registers to um, basically put this there implicitly, so you only have to put the last four, which is what is happening in most of the case. Um, and to be Sasmo. Um, like here, we can see it's like this address will really only be looking at the 5 9, and the plus 24 is like an extra part of the thing, but the 5 9 is pointing to this string here. I think that's in view. Yeah, I might way over here. But yeah, so I thought I'd kind of step through what is happening here. So we set up some extra, the segment registers, I guess you could say. And then you do a bunch of int codes. Well, you do some int codes. And whenever I get an int code, I have to come and look and see what it all means. So an int code is made up of two parts. So you've got the actual int address, and then you have whatever AH is set to. I might get rid of this. Yeah. Um, so it's made up of two parts. So the first part, gosh, how I was just on the other keyboard before, and I feel like this should have errors, but it is not. But anyway, we're looking at int 10. So we can see int 10. Maybe I was off by one. and it's looking at F is uh, that, so we can look up golly F, and it will say this is get video state, and on return it will set these things here into those registers. So I've kind of gone through and worked out what all these int codes are to put a comment in to say this is what this code does, just to make it a bit easier. And to start with, so I might just copy that. And to start with, all your functions look like this, and you just have to go in, and then there's like more functions. Like it's kind of nuts. Yeah, that's what I want, and I want to just set that back to that. Um, so with this, we can go in and kind of how I had to do it was go through and work out, right, this is doing this, and then, oh gosh, what does this one do? And you kind of have to drill down into each thing. And here we can see it wants to print a string. So I'm like, okay, where's this DX? So DX is 7750. So I can go to an address and um, maybe I can go to 7750. And we can see here it has the amazing Spider-Man something. But if I go back to uh, run a what is it, games DOS Spidey, and then maybe we'll DOS box X Spidey, Spidey, Spidey. So if we run this, it starts off saying the Amazing Spider-Man with a bunch of stuff, and so this is kind of useful to see. All right, it's printed a bunch of stuff, and that's when you get used to looking at x86 like low level. This is quite clearly checks mode VGA, which it will know that it's doing that, and like this function is to gosh, it went out a bit. This function is to um, print a string in text mode, I believe. But yeah, so if we jump back, so it prints the title string, and we keep going back, and then we do like I've kind of called it wait until no key pressed. It's a weird function. Um, but yeah, we get the keyboard status. If so the zero flag is set to one if no keys are pressed. The low level int functions like just it's like they didn't have enough registers and they just started making up stuff. But yeah, they kind of changed the zero flag for some reason. So if the zero flag is on, uh, then this jump zero will happen. So if no keys are pressed, we will return. Otherwise, we'll do a blocking read pretty much, and then go back up to the top here and try the same thing again. So I think the idea is this is kind of making sure that nothing's if you started the game with a key held down, which I wonder if I could kind of emulate. So when I get a window, have I got a window? Uh, yeah, so it does like some weird things. If so, I held down a key before it's doing, and now it's going through that loop, just trying to work out um, things. Wait, I've stopped. I've stopped. Um, oh, I did that a bit too much. So we can kind of see that this is doing some things. Keeps on jumping to like oh, I've got two of them open. That's why I've got things. Ah, yes. Which one do I want to save? Oh, they've both got things open. I had like work done in one. I don't know why I picked up another. Um, well, I feel like I don't know. Like, what did I change with it? Was it just I don't know. I've saved that there now, and that seems fine. Um, sure, and we'll keep this open. Right, let's not do that again. Right, so we. It's a bit of a janky tool, but it is what you get. It does a pretty decent job, and you'll see down the side here it's got some C code, but it's a bit trickier to read when it's like real mode stuff because yeah, it's a bit trickier. So we wait until no keys are pressed, and then we straight away read a key. So that's like when there's no keys pressed, it wants a key to be pressed. And if we like if we get this going, it wants us to say whether we want VGA, EGA, 10D, or CGA. And what it does is it gets that, then it subtracts one, so it has basically got a value of 0 to 3 now. Well, hopefully 3. It checks whether it's 3, otherwise it goes back and tries again. So if I put in 7, it won't do anything. But as soon as I say, I don't know, 4, it will go to the next screen. How does it get to that next screen? Gosh, a lot of steps in between. Um, so we check the option, we return from there. So that's like initial start screen. Doesn't always get to it from the right place. Um, the gist is that this function reads the file, but it does a check on whether the mode is one of the 4-bit ones or the 16-bit ones. And depending on that, it does certain things. But the gist is that we're reading some stuff into memory. I'm imagining that if it's so, this only does it if you're 4-bit. So I assume if you're 16-bit, this is kind of already kind of loaded in memory for some reason. I'm not too sure. Um, we go and do like setting graphics mode. So this is also something that I do in like operating system reasonably early on. I don't do graphics mode though. I just do text mode. But if you do graphics mode, you can get a kind of higher resolution like this. I mean, you can get up even higher than that, but this is just 320 by 200 for both of them. And it basically sets that up. And after it does that, does some color palettes, and now I can say that I have dived into it. Um, how do we just do that? Um, and then it will load the windscreen into there. Oh, I'm not too sure why. And here it does like a kind of odd thing. Which I can't quite work out why. And it's kind of interesting. If I go and run it from the start, it's potentially my DOS box setup. I don't know. I can probably look into it, but if I try and run one of these two 16-bit ones, either one or two, I just get nothing. It kind of just goes into an endless loop. So I'm wondering whether there's something there, but either or, I'll just work through the code and work out what happens. So basically, if you're 10 or CGA, you read a bunch of the CGA files. So the spids 1, spids 2, a whole lot of them into different parts. So like you have different data segments and ooh, all sorts. And then it gets to a weird point, and I'm actually a bit of a loss. If anyone knows how this works, basically ghidra sends me to a function that it can't decompile, like bad instruction. So I'm not too sure what happens there, but that's kind of the end of the flow of where the Tandy and CGA stuff go, which is interesting because that's the version that works for me. But I've gone through on the VGA and stuff as well, and we load the backgrounds into there, then a bunch of other stuff. We collect some interrupts and we do some things. This I didn't actually comment what it was doing. Ah, that's right. We set ES to be 0, but there's actually like memory mapping going on if we look at the memory map. Um, so here, it's lovely small font here, sorry. But here you can see all the different start addresses, so that those are the valid segment registers that you can do. Notably, there's none for 0, so nothing is loaded at memory address 0, except there are some things there. Magic thing. Magic. Yeah. So a couple of things that are there. You have like your VGA memory that you can kind of poke into and read out of. If you're in text mode, then you have a different bunch of memory that's mapped in. Um, so I've kind of left this bit alone because it's probably doing some VGA stuff, and it doesn't seem that important to what my goal is working out the file format. But it's useful to know that it's doing something because you don't want to miss what it might be doing. But at the end, it just resets it and continues on. Gets the time, stores that in a couple of things, the same value in two different places. Not too sure why. And then we do the language select. Um, Again, interestingly, on my copy of Spidey, I'm not too sure why, but if I say, I don't know, do Espanol, it seems to just be in English. So I don't know. It's like they're pretending to have languages, but not actually have them. But maybe it's just my copy. But yeah, so the language select is we do that load screen. So I'm guessing that load screen is kind of setting up the CGAs to be able to kind of act like a VGA. I'm not too sure. But it does some things, and this does some video things. And it goes and does more video things. And you can see here I have gone through to work out. Um, so this is doing some like out calls. So this is where you have like input and output ports, and the port number in this case is DX, and the DX was set to 3C4. So we can see what 3C4 is if we have a list of ports list, and in here we can for 3C4 was it, and we can see here that it is to do with EGA and VGA type things. And so depending on which path we were in here, I'm not too sure which path it was. We do video things. Just video things. There's just video things. Just video things and more video things. So yeah, I haven't really delved into that too much. But this is still just picking the language. So we, I think, redraw the screen here. So in this loop up from here, where that handy arrow shows. And I think this is doing a redraw, but I'm not too sure. Like, I could dive into exactly what it's doing, but it's got some quite significant loops that are going over into an address that I know is the video memory. So I think that is kind of doing the redraw. Then we do a weird as function. Again, not too sure what happened here. There's no return. It just kind of falls off, and it's, yeah. And also this function, oh, opcode, says it should only really come after a sub, not after an inc. So I'm not too sure. Uh, but yeah, we do that. We wait until no keys are pressed, and this is kind of cool because this is a function that I had already gone through to work out what happened. So when I came through to do this, I'm like, cool, this is waiting until nothing's pressed. And then I can see here, this is the same int code. Right, now we're reading a character. And now we're trying to get a character that is between, a number that is between 1 and 5, but it stores it as 0 and 4. And that just so happens to line up with the options it's giving you there, which is kind of interesting. Then it takes that number and kind of does a bunch of multiplications on it. It's kind of interesting they've done like a bunch of ads like this. You can do the same thing because this is just multiplying. Like if you add a number to itself, it's multiplying by 2. You can do the same thing in assembly. Well, machine code, just by shifting left by 1 is the same as multiplying by 2. And if you're going to be multiplying by it 2, like, 5 times, you can just shift left 5 times as one instruction. But I don't know, I wasn't making the game back then. What is interesting here is this 621D had rooms. Well, no, it hadn't had it. Or had it. So we go back up to here. Yeah, I think it hadn't loaded rooms.spl, but it loads it into that 621D, which I found interesting. That this kind of gets that 621D, but then adds a bunch of stuff based on the language. So potentially this is meant to be kind of looking up the language code and then, well, like the address to a language pack. And mine doesn't have it, or I don't know, it's all the same and all in English because someone only bothered written it in English. Who knows? Um, and then I think I stored that one line to 1E. Yeah, so yeah, cool. And I've got some notes, and I don't know, I can put those somewhere once I've got a bit better. It would be kind of cool to have like a big memory map of like, this is what happened in this chunk and this chunk and this chunk and this is what's loaded here. Blah blah blah. But yes, so we get the language, then we shove that there, then we do that function that we had already done. I thought, yeah, I thought this one had already been done. Then you do a big knop sled, and the knop sled kind of makes me wonder whether like that's too much for like kind of boot code type thing. So it makes me wonder whether something is like jumping to here, but ghidra hasn't worked out any points that do. Anyhow, it now reads rooms.spl into this chunk here. And so this is where I'd kind of got up to. So I've got this function here. And I'm just kind of drilling into everything in hopes of seeing something that reads from 6 to 1D plus some offset, and then see what happens with that offset. Does it go through a random function that looks like it's decompressing thing? I mean, I've already got an idea on where to start with the decompression, but yeah, um, there's more stuff to go. But yeah, I thought this could be kind of cool to kind of continue on. And this like entry function, it just keeps going on and on and on. And I would imagine at some point there's like a big loop or something, or it calls something that has a game loop. But I don't know. There's a lot of code and there's a lot of functions that look like I've got a fun time ahead of me. I do know it exits somewhere, um, but yeah, um, there's quite a bit of code. So it's like a not small journey, but I thought it would be kind of cool to talk through some of it. So what have I done? I guess at this point, what I could do is figure out where I got up to. Are we still in the entry? Yeah, so I want to kind of jump into this function. So I haven't worked out what it is. And I thought, I don't know, maybe I'll show my working out what things do. So first thing here, I can see that there's a variable being used, and in my head, I know that the data segment is still the same as it kind of always has been. That's um, uh, it is this 1FB3. So what we can do is see what that 1FB3 at 387. We can see it is 0 to start with. And we can also, I don't know, come find a like, I don't know, chuck it somewhere here. I mean, it's not really sorted in any way, shape, or form. But this is set to one function shortly loading rooms dot SBL. And so to future Hugh, that might be a clue. Maybe there's something happening in there, but it might be a red herring. Who knows? But it also compares with. Apologies if it does that. The jankiness. It's like popping up a thing down there because I don't know. I'm using a tiling window manager as well, so part of it's on me. I think if I do something like this and then do something like uh, no, I want that to be down there, but uh, I don't know. Enough demonstrations of that. I want this to be maybe like that small. Cool. So I also have 11E. Do I have that? Yeah. So we also this is set to 1 just after that function. So this was let me remind myself. I think it was in this. Yeah, so it sets 11E based on a result of a bunch of ins. So it does a bunch of inputs. Uh, yeah, so it does this in value. So it does quite literally a bunch of inputs. And again, it kind of just runs off with no ret. So I'm not too sure how this bad boy gets home. But if we do that, then this, no, not that function, one up. If something good happens. Sometimes you gotta do it twice. Then I'll go to success I've labeled and it will set that bit to be 1. Uh, so in this function, it checks whether that is a 0 or a 1. And we know that this got set to uh, got set to 1 shortly before this function. No, this uh, gets set to 1 based on a bunch of ins and assure what or how. Because I don't know, I haven't really worked out, and I think that one was actually a little tricky to kind of work out because um, it uses a bit from memory, which I haven't seen get written in the kind of adventures that I've been doing. I haven't looked too hard, um, but I don't know. I thought I had looked reasonably hard enough. Like I stepped down from entry all the way down to here, but hard to know. So I'm not too like that value must be pulling from 0, but then like what a 0 would just be that 0 0 0. Do you have how do we figure out if you've got something just at the start? So it kind of seems like it. I don't know why that one didn't show up. Maybe that's the tab. That's why. Um, so it's potentially looking at that, but I don't. Um, but if it was 0, um, then it would then jump. Otherwise, it would do this, and this jump goes all the way down to here. So this one kind of uh, just returns. So what I usually do is just kind of label it as well, maybe pop and turn. Um, so that way, if any other jumps in this function jump there, I don't know what it does, just at a glance. Um, right, so then this does the same, it calls that same function doing and so it's basically doing the same as what the other one was doing, maybe with different values here. I'm not too sure exactly how it is going. Um, Potentially, I don't know, could be anything, could be anything. So, um, then at the end, we have like a little jump back. So this kind of means that we've got a loop. So I might say this is a loop. We have a function we don't know about. So what does this function do? And this is getting that 387, which, what, it was set to 1 in a function shortly after. So that was set to 1 at the start of this. So that's potentially just saying it's getting initialized. Um, yeah, so I'd say then to 0 at end of initializing variable. Um, Something like that. But what does this function do? So we have to drill into this. And the sad thing with these functions is I have to kind of remember kind of the context of what things are at. And gosh, I didn't notice that there's things getting run into memory here. Um, and so I wonder if Oh yeah, there's like random, lots of random bits. Nah, there's only a couple random things. Um, but yeah, that could be worthwhile. 38A set to 0 in action. So I'll just have to remember not to move these too far away from each other. 9 set to 1 in the same function. Um, so these could be a thing. Now this, what are we doing here? So we are setting get out of it. Um, yeah, yeah, yeah. Cool. We are setting bx, which is 0x 38c, but plus 5. So c plus 5 is what, d, e, f. But then we roll on over, and then we get 0, 1. So it'll be 1, but not 1. And what was I saying with this? Set to 1 in the same function. Well, actually, it's in a loop that goes up by 10. So maybe I want to say 3, 8. Come on, 3, 8. C plus 5, then plus 0x a. Um, loop, and where's our c? So this loop takes the cx, 0x b times set to 1, and this will be plus 6 and 0 there. Got to make sure you watch out for those loops and kind of how they're going. So this is something that is adding by 10 each time, and then uh, doing it what 11 times. So we're going 111 kind of thing, but yeah, I'm not too sure what that is put meaning at the moment, but it could be some booleans, could be some something. Who knows? Um, but yeah, we set that back. So what happens in here? And so with all that talking, I kind of need to keep track of what BX might be, because it looks like, oh no, BX gets overrun. Well, BL gets overrun and BH gets cleared. So a XOR of the same thing will clear itself, and BH is the same as uh, BX is the same as BH shifted H plus BL. So this overwrites the top half, and then this kind of sets that from 38A. So that's kind of interesting. So this is set 38A that is set in this function that calls it 38A. That's set up there. So it's set kind of, it will always be 0. That is if this is, not that one. Um, if we have a look see and see, this is only called from one place. So it's called from this place. So it's kind of an odd code, but 38A should be 0. But it could be overwritten in uh, um, interrupt handler or something. There is an interrupt handler live at the moment. It was set up. It handles double faults, but I think everything else wasn't handled, which is interesting. Um, was set to 0 just before the soul or site of this function, just so we know. So that means that bx will be 0. So then this is going to be 0 plus 2 6b5, but from ds. So what if we look that bad boy up? I think this keyboard's got a updated firmware. The arrows aren't quite working, and this tool unfortunately requires arrows and mouses a lot more than I usually do. So that currently has 0 in it. Uh, if bx equals 0, then this has 0 in it initially. Uh, and yeah, it makes me wonder whether that's not anything, because now we're like, I've got the hypothesis that this is 0, which like it surely is, because we set 38a to be 0, and that's like not in a loop, no arrows down there. So it should go through here and then go here, and this is only called only reference from there. So 38a should be 0. That's my thinking. So 38a should be 0. So this should be 0. BL should be 0. Then BH get zeroed out. So BX should be 0. But then we load BL from whatever that is. But if it was 0, then we double it, and then it's still 0. And then we get a slightly different one, C6. C6, also 0. And then that gets set to DI. Now, DI and SI are slightly interesting. They have certain operations on them, or opcodes, that when used will increment SI and increment DI like that. Or if a certain flag is set, it will decrement them. And the idea is you copy a chunk of memory between the two. So what happens now? We have a loop by the looks, and this is our only loop in here, so we can go loop. Um, all right, what's this doing in it? This bit's confusing me because I see this as just getting 0, so di is just 0, and bx is 0, and then that flag just did. Yeah, I don't know. Something, my hypothesis is wrong there, but it seems unusual because 38a was set to 0 just before. Interesting. But yeah, here it just keeps on going nuts on that. No, we do actually set bx to be a bit better of a value here. So yeah, 38c and 38c plus 5, and this is going up by 10, or a. So this is doing this, and the loop is b times. So this is a very similar loop to the last one. But what are we doing here? We're setting that first value to 1, which is similar to that. So I don't think I'll kind of cloud it with another note. And then DI, which was pulled from there, which I swear is just 0. I don't understand how it can't be. Like I guess the value gets pulled in from somewhere else. Maybe that's a like special value. Hard to know. Hard to know. And I don't think the DS has changed on me, but it potentially has. So you can step through in like DOSBox S, so they have a debugger. So I might look into using that to work out some of the stuff because I do note that I'm not even past the screen, but that's all right. So now that I've kind of read through this function, I have to kind of get an idea of like what does it do? What's it doing? We're adding something to DI every time, and we're like kind of overriding that. So plus, so this is going to be a +8, set to something that's going to be set to stuff in a loop called from the same function and just point up to there. Um, so I've got a few things that are kind of loaded off each other, which at some point I'll write it up. But yeah, so I'm still kind of at a loss as to what this is kind of doing. This is fetching some stuff from potentially very low down in the memory, which isn't really a good sign. And what it's called kind of just at the end of this function, which I still need to kind of work out what's happening. Um, so I think what I'll do is leave this unnamed, and I will kind of also leave this unnamed, but I could name it something like, well, it had what? Sets structure value at 0x38c, because I think that's what it's really doing. And it's got like an initialization flag, which I think I can kind of label that address. So if I see that later, I know what it is. The 11e. Oh, we didn't know there. There was like initialization things, then we just do that, and then we pop and return. Do we have a 10? I'm not sure I saw a 10. Not that one, thanks. It's 10. Yeah, so we do have that after the interrupt handler is swapped. Do we check it? Like, we don't actually check it, but I wonder if that is getting set at some point, maybe in the interrupt handler. Um, so yeah, I guess I don't really know what it's doing, but I did set that. But then this function, I haven't said what it's doing, but that's also kind of part of that whole bigger structure. So we get to stuff here, and this 38c, I am not sure I have seen before up here. Yeah, and that's all the CGA stuff. Interesting. Because was it always at oh, we like push D and then we pop it straight out. No, we're pushing DS and CS, but we're popping CS. So DS equals 0x 4 409 one. So that's the same as the code segment. This changes everything. Maybe if I come here and just figure out. Is this 387? Yeah, so this all stuff is kind of set when ds equals what did we say it was 4091 0x 4091 uh 4091. Yes, we don't have that. And what did I reckon about 11e's? Yeah, so that 11e was also there. But then that was set up here, and that does the same thing. Um, Note ds equals 0 changes so many things, and it's scary because this is overriding code at some point. So this 11e, we can even see that 11e is like just above here. Um, that's scary. So if we no, don't yeah. Uh, if we go to this and search for what 4091 and then 11e, it is this address. So I guess it's like a variable up here. So um, it doesn't really know where it is though. Yeah, so it's thinking it's 00, but that does change some things. So that means that these two are kind of down there. And 11e, so that's install 11e. Now, what happened in this uh, timer? Um, this did we write down that? C and E. Yeah, I'm not too sure what's happening there. I mean, that's kind of it's doing timer things. It does something. I feel like the data segment seems like it should not be what it seemingly is. Yeah, here we go. So this means ds 0x491, and we can say here maybe when we do some things, ds equals cs equals 4091. And so now we can look, well, 4091 and 1 colon C. And that address is there, but it will get stored as something. And E was just a couple more, and that was also 0. Any more memory things that I wasn't seeing? We're writing to 11 and a 13. How was that something that had up there? Yeah, 11 and 13. All of this stuff was also down there. and I think I might say this is CS as well. Cool. So, maybe give that a little save. Go back one more from there. Go back one more from there. And this was, yes, setting 11E based on that. Oh, it's so gross. This is why people don't like assembly. It's because you can do curse things, but it works and it's usually efficient. Right, we're setting uh, uh, setting ds back to 0x1fb3. So that's our main one. So it did get changed. It should have got changed back, but good to check that it is. Uh, and yes, and so was this the function that we were? Now the 7f shouldn't exist in. Oh no, 7f might exist in this one. So if we look at one, if yeah, that one there, and 7f, this is a thing, and it's referenced from a couple of other places, but it's very short after that start seconds, which I thought start seconds had a start seconds 2, which was shortly after it. Nah, it's at the end. Gosh, there's a cheat. I might find the cheat. It's just what you get. So that is a thing. And where was it kind of read from? It was read from a few places. That's not this function. What about here? It's like looking for a 3F when it's looking there. And right, what was this one? There was just checking, moving it and calling it to a thing. We don't know enough about it to say for certain what it is, but we set this to 1. So 0x7 7f set to 1 after rooms.spill. Also checked against 0x7f later in diff functions. Something like that. Right, and so what are we doing here? We're doing lovely. So we're in a function and we're just jumping to somewhere, which happens to be in the middle of a different function. It's just something you're allowed to do. I potentially was actually just jumping from there, and it wasn't really, but yeah, it's a kind of interesting way of doing it. So that's like a loop initializing loop in it, and then this will be the loop itself. So it's, yeah, it kind of does a thing. So we get di. Di is 80 to start with. So we have 0x80 set to 3, then 0x81 dot dot wait dot dot how much were we going? plus 0x C8. So we're doing a loop of this many. The first time we set it to 3, and then we set it to 0. Set to 0. That 7F is an interesting one to kind of think about. So if we look at our rooms, if we search for, was it not a 7F? It was an 8F. It's an 8F. 8F, I believe, is the header byte, like the first byte that you'll see in a room field. So there's one starting here, there's one starting here, and you can see here that it actually no, there's one starting here. It can start mid byte. So here we can see a midnight, and then in this little chunk we can see a forward, and in this little chunk we can see a left, and in this little chunk we can see a shaft. And then this little chunk, Black Thunder. And the shaft is notably a lot smaller than the other rooms. Like there's less tiles and stuff to handle. But yeah, interesting stuff. This notably is clearing the direction bit. So I need to look it up. So CLD. So CLD clears the directional flag when it is set to 0, so cleared. It will increment. So this will increment SI and the I. It's kind of interesting because I have never seen the other one, which is SLSID. There's a set direction STD, yeah, STD. You can get STD and STI. I've seen the STI, but I haven't seen the STD in here. Sorry, lame joke. People from the 70s made these manuals and made these things, so I blame them. Right, what is happening here? So 8110, have I seen that? Let's not do that. 811. Yeah, so I know that at this location, mover tab.dat is stored. So what I can do is just put a note, mover tab.dat stored here. And I say if EJ or EJ, but like what happens with the dandy stuff, it potentially has like caught up and is doing the same stuff as now, but hard to know. And this one here is like a repeat. Yeah, so mov sb dot rep. So what this will do is as many as CXs, so that 300, well, 0x300, a lot more than 300. That many times it will kind of move from SI into DI overall. And the SI is loaded from the DS, I think, or is it both from, well, we can go to mob. Yeah. Yeah, so is this just what I want? Yeah, it's like a big long one. Yeah, so it moves it from DSI to ES. So DS was I can't recall. I think it's just standard now. I think it's just standard, and ES I think is also just standard. So I think these are both kind of that. But what's DI 148? So 0x148. Move the tab dot dat copied. Yeah, after might be not a good place for there. Who knows? So what is this doing? It does like a little extra stuff up here. I'm unsure on the reason for it. Like that's doing some stuff to like just a different place. Yeah. Anyway, but in general, it does like a moves the mover tab. Moves well copies mover tab dot dat with the other stuff and more. Um, it's just really to let me know what it means when I look in the big main function. So this is the init, and you can even see it in the init. It has a bunch of comments, and here I can see it copies mover tab dot dat and more. So I can kind of know, right, that's maybe what it does. Still don't know what it does. So at this point, I think I'm going to give up because I've done a bit, and I think I have kind of given a good introduction to what my plans are. It doesn't mean I'm giving up on certain other plans that you may have seen on this channel, but it's just something else that is keeping me busy because I like to keep busy. But yeah, let me know what you think, and if you're excited about this, or you have, if you can tell me how to do any of the stuff I'm doing, because I'm kind of making it up as I go. But I've got some kind of experience, you know. But feel free to leave a comment. Let me know how I can do things different. But for now, thanks, and I'll see you next time.